Hello, myself Dr. Vijay Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss regarding the definition and terminology of Module 5 about multiprocessors. What is parallel processing? So, parallel processing is used to provide simultaneous data processing tasks for the purpose of increasing computational speed of the computer. So, the major characteristic of parallel processing is simultaneous data processing task execution. So, in a multitasking systems, more than one task can be executed by the computer at a time. And to support the multi-user and computational incentive applications, this parallel processing can be required. So, concurrently, more than one task can be executed so that the performance and computational speed of the computer can be increased. So, parallel processing systems are able to perform concurrent data processing. Parallel processing systems are required to meet the demands of large-scale computations. So, here data incentive applications can be performed with the help of the parallel processing systems. So, here nowadays all the systems can use big data technologies, cloud computing technologies, blockchain technologies. These technologies require large volumes of data for processing so that the system can support the parallel processing and the task can be executed concurrently with the help of these parallel processing systems. So, execution of concurrent events in the computing process to achieve computational speed is referred as the parallel processing. Parallel processing can be achieved at various levels. It can be applied at the job or program level so that multiple programs can share the data and can execute concurrently. And at the task or procedure level, with multi-threading concept, the task can be parallelly executed. Inter-instruction level and intra-instruction level, the parallel processing concept can be applied with function calling mechanisms and with multiple program data sharing mechanisms. Second definition is, what is vector pipeline? Vector processing is the central processing unit that can perform the complete vector input in individual instruction. The input can be the complete vector for processing. The science and engineering problems can be solved or implemented by using the vector processing. So, with the help of matrices and vector processing, scientific and engineering applications can be implemented easily. The features of vector processing pipeline are: a vector is a structured set of elements. So, generally, the vector can consist of rows and column. Organized data can be used as input for this vector processing. Each clock period processes two successive pairs of elements. So, thereby it has to support the parallel processing capacity. Vector processor implements better with higher vectors because of foundation delays in the pipeline. So, more data processing can be required for scientific and engineering applications. So, they can use the higher order of vectors and If at all the order of vectors can be increased, there should be a delay in the pipeline execution. Vector processing decreases the overhead related to the maintenance of the loop control. So repetition execution of the task can be controlled with the help of the vector processing. Next, what is flying classification? Multiprocessor systems can have capacity and contain more than one CPU in a single system, support parallel processing. Flying classify these multiprocessor systems. MJ Flying classify the computer system by the number of instructions and data items that are manipulated simultaneously. So depending upon the instruction stream and data stream, MJ Flying classify multiprocessor systems into 4 categories. So the classification can be based on the instruction stream and the data stream. What is instruction stream means? The sequence of instructions read from the memory. So the fetching of data from the memory, whether it is a single path or multiple path, can be specified with the help of instruction stream, and the data stream can specify the operations that are performed on the data in the processor. So depending upon these 2 factors, so the flying classify the multiprocessor systems into 4 groups. One is SISD, second category is SIMD, third one MISD, fourth one MIMD. SISD means single instruction stream, single data stream. SIMD means single instruction stream, multiple data stream. MISD means multiple instruction stream, single data stream. MIMD means multiple instruction stream, multiple data stream. So whether the instruction path is a single bus or a multiple bus, how data operands can be fetched and used in the computation can be specified with the data stream. What is the single instruction and single data stream multiprocessors? So they represent a single computer containing control unit, a processor unit and a memory unit. So the functional units of SISD architecture are the control unit, processor unit and memory unit. And in this type of computer, the instructions can be executed sequentially one after another. Parallel processing can be achieved with the help of multiplicity of functional units or with the help of pipelining processing. In a multiple functional units are employed, the each unit can be implemented one specialized functionality. For example, one functional unit can be used for integer manipulation of data like addition, subtraction, multiplication, division, and one more functional unit can be employed for floating point arithmetic operations. So each functional unit can be designed with a specialized task so that parallel processing can be supported in SISD architecture. Or with the help of pipelining concept, the parallel processing can be achieved in the SISD architecture. So with the pipeline, the phases of instruction or the segments of the computational processing can be overlapped, executed and to solve the problem. So here in SISD architecture, parallel processing is supported with multiple functional units or with the help of pipelining concept. Here, the maximum speed of SISD architecture can be limited with the memory bandwidth, and this memory can be shared by the CPU and I/O devices. The architecture of SISD can be illustrated in this diagram. So, this is the processor. Only the single instruction stream and the single data stream can be connected to this processor. Next is SIMD. So, here this refers to single instruction multiple data stream. So, this represents an organization that includes many processing units under the supervision of common control unit. So, all processors can receive same instruction. Why? Because it is a single instruction stream. So, same instruction from the control unit, but they can operate on different items of data. So, multiple data stream can be employed. The shared memory unit must contain multiple modules. So, this is the architecture of SIMD. The processor unit can take instruction from the instruction for a single instruction and can be shared with multiple processor unit. But the data stream is a multiple data stream for each processor. Next architecture is MISD. Multiple instruction stream, but data can be the single one. That means instructions can be fetched parallelly, but only one data stream is available to perform operations on the operand. So this is more impractical and not used in the market, the MISD architecture. From the instruction food, multiple paths can be used to connect to the processor unit, but from some data pool, a single path can be used to connect to the processor unit. So this type of architecture is referred to MISD architecture. Next is MIMD architecture. MIMD systems are capable of processing several programs at the same time. Why? Because multiple instruction stream and multiple data stream is employed in this architecture. So these systems are suitable for multitasking systems. So here the processors can be connected with multiple instructions to the processors. So the bus can use it to connect the fetch parallelly more than one instruction, and the data pool can use it to connect to the each and every processor. So multiple instruction path and multiple data paths can be employed in the MIMD architecture. So these four architectures are classified by the fly-in. Next definition. What do you mean by pipeline processing? So the parallel processing can be achieved with the help of implementation of multiple functional units in the system or with the help of pipelining processing. Now we have to discuss what is pipeline processing. Pipeline processing is an implementation technique where arithmetic sub-operations or phases of the computer instruction cycle can be executed in a overlap fashion. So, if at all a computational task can be processed by the system, this task can be divided into sub-tasks or segments. Each segment can be executed in a parallel in the dedicated registers, pipeline registers. Or in case of instruction cycle can have the 4 steps for executing an instruction. That is fetching the instruction, decode the instruction, fetch the operand and calculate the effective address, and execute the instruction. So these phases can be executed in a overlap fashion with the help of pipeline. So two categories of pipelines are available. One is arithmetic pipeline. Second one is instruction pipeline. So pipeline is a technique of decomposing a sequential process into sub-operations. So the major computational task can be divided into sub-parts. Each sub-process being executed in a special dedicated segment that operate concurrently with all other segments, thereby supports the parallel processing. A pipeline can be visualized as a collection of processing segments through which binary information flows. So this is the one way of speeding up execution of instructions. So as a summary, an overlap execution of multiple instructions can be considered as the pipeline. What is the key idea behind this pipelining? So breaking big computational into some small pieces, separate each piece with a pipeline register. It is faster for repeated computations. Pipelining increases throughput. So how the overlap execution can be implemented with the help of pipeline? Now consider one example, one computational task which is to perform multiply and add operations for a stream of numbers. So consider A and B, two numbers that can be added, that can be multiplied and added with the third number C. So this computation can involve multiply and addition operation, but this can be with a stream of numbers. So the stream can be the numbers 1, 2, 3 until 7. So the I value can be 1, 2, 3 until 7. So this computational task can be divided into parts. Those parts can be referred as segment. So each segment has one or two registers and a combinational circuit to implement this computational processing task. So how this computational process can be divided into parts can be, the first part is loading of the A and B values to the corresponding registers. So that it can be considered as the segment 1. So A and B values can be loaded to the R1 and R2 registers simultaneously. Next, this computational task can be divided into next operation, that is multiply and input C. So here the loaded values A and B in the corresponding registers of R1 and R2. So these values can be multiplied with and can be stored the R3 value here, and at the same time the C value can be stored to the R4 register. This is the segment 2. And segment 3 is adding this C to the product. So the product is stored in the register 3. It could be added to the R4 and the sum can be stored to the R5. So this is the segment 3 operation. So this computational task can be divided into 3 parts, 3 segments. In the first segment, input operation can be carried out, and in the second segment, multiplying and input to the C third value can be carried out. In the segment 3, addition to the product is carried out. So in each segment can consist of 1 or 2 registers and a combinational circuit for processing. So how they can be in the pipelining, each segment can be represented with the flow diagram. So here the registers R1 and R2 can be stored with the 2 input numbers A and B. This is the segment 1 operation, so that they are storing in the corresponding registers. Later on in the second segment, multiplication of these two numbers can be carried out and the result is stored in the R3. At the same time, the third value can be stored in the register R4. So this is the segment 2 operations. This product can be added with the help of adder circuit with the third number stored in the R4 and the result is stored in the register R5. So this is the segment 3 operation. So the computational task can be segregated as segments and each segment can be carried out with the help of one or two registers and a combinational circuit. And during the clock pulses, how the operations can be performed is defined and can be illustrated with the type diagram. So the timing diagram can visualize how in each clock pulse the overlap execution of segments can be carried out in the pipeline. So it is used to pictorially represent the behavior of the pipeline. So here during the first clock pulse, the segment 1, so I value 1, the first A1, B1 values can be loaded to the registers R1 and R2. This is the I value 1. And during second clock pulse, the I value 1 values can be moved to the segment 2. There the product can be found and can be stored in the R3. And at the same time, the third value can be loaded to the register R4. At the same time, concurrently, I value 2 instructions can be initiated and are stored in the registers R1 and R2 respectively. During next clock tick, the I value 1 instructions can be moved to the third segment. There the product can be added to the third value. So that I value 1 computational task can be completed here at the clock 3. And here the second values can be moved to the segment 2. The product can be identified and parallelly the third value can be stored to the particular register. This is the I value 2. And at the same time the I value 3 can be, the values are stored and loaded to the R1 and R2 respectively. So if you observed at the third clock tick, 3 instructions are executing in parallel. So this is the overlap execution of the segments in case of arithmetic pipelining. Next, what are the stages of RISC pipeline? So RISC stands for Reduced Instruction Set Computers. The instruction set generally provides an interface between the software and hardware. So here the instruction set provide variety of instructions for manipulation of operands. So these instructions can be reduced and optimized in the RISC architecture. So RISC was introduced to execute as fast as 1 instruction per clock cycle. And RISC pipeline help to simplify computer architecture design. Why? Because it is a reduced instruction set. Few number of instructions can be available. So the method to obtain implementation of an instruction for clock cycle is to initiate each instruction with each clock cycle and to pipeline the processor to manage the objective of single cycle instruction execution. So generally the instruction can be executed minimum 3 cycles. But in the RISC architecture, it can take a single clock cycle for instruction execution. What are the principles of the risk pipelining? So keep the most frequently accessed operands in CPU registers so that they are readily available for the processing. And it can minimize the register to memory operations. So frequent fetching of operands can be minimized here. And it can use a high number of registers to enhance operand referencing and decrease the processor memory traffic. So the number of registers, general purpose registers, are high in case of RISC architecture to minimize the frequent referencing of the memory and to reduce the processor memory traffic. It can optimize the design of instruction pipelines so that minimum compiler code generation can be achieved. It can use a simplified instruction set and leave out those complex and unnecessary instructions. So it is a reduced one. So 3-segment instruction pipeline can be used here for a instruction execution. So what are those 3 segments can be? The first segment can be referenced with I and it is instruction fetch. The second instruction is ALU operation. The third segment can be referenced with E and execution of instruction. How the timing diagram of risk pipelining. So these are the clock signals. So during this clock signal, the instruction can be first I value can be fetched. And in the second clock cycle, ALU operations can be performed. And in the third clock cycle, execution of instruction. During second clock tick itself, the second instruction can be entered. During third operation, next instruction can be loaded into the fetching of instruction can be executed. Next, what are the pipeline conflicts? So, pipeline is overlap execution of phases of instruction cycle or segments of arithmetic operation. So, here the data can be shared between the segments during these overlapped execution so that some conflicts can be taken place during pipeline processing. There are 3 major conflicts. One is resource conflict, second one is data dependency, third one is branch difficulties. What is the resource conflict? So when the operations or the instruction can reference the memory at the same time, these resource conflicts can be arised. So caused when 2 segments are accessing the memory at the same time, then this resource conflict can be occurred. This problem can be overcome with the help of separate instruction and separate data memories. Next type of conflict is data dependency conflict. Data dependency can occur when instruction depends on the result of the previous instruction, but it is not available. The result is not available. So, the instruction execution can be depending on other instruction result, which is not available. So, the data dependency problem can occur. So, the operand access can be delayed to mitigate this data dependency problem. Generally, 3 techniques can be used. One is hardware interlock. With the help of hardware locks, the operand access can be controlled. Next is operand forwarding. So, the required operand for execution of instruction can be forwarded for the process. Delayed load. Operand access to the memory is delayed until required data is available. So these techniques can be used to resolve the data dependency conflict. Next is branch difficulties. So these difficulties can be erased from the branch instructions or the instructions that modify the value of PC. So during jump instructions, call instructions, the value of PC can be modified. So during that time, these difficulties can be erased in the overlap execution. To resolve this problem, prefetch target instruction, branch target buffer, loop buffer, branch prediction, delayed branch techniques can be used. So they can use some hardware buffers to save the return address of the program counter. Next is, what is the difference between vector and array processing? Array processors are also designed for vector computations. Vector processors uses multiple vector pipelines. An array processor employs a number of processing elements to operate in the parallel. Generally, scientific and engineering applications can use the vector processor. What are the disadvantages of pipeline? So, designing of the pipelined processor is very complex task. So, the conflicts that can arrange the data dependency, branch conflicts, resource conflicts can be properly taken care with the help of hardware mechanisms. And instruction latency increases in pipelined processor. So, the data dependency problem, if not mitigated, then latency can result in the pipeline. The throughput of pipeline processor is difficult to predict. So, it is increasing or decreasing. If it are more delayed occurred in the pipeline, the throughput can be decreased. And the longer the pipeline was the problem of hazards for the branch instructions. So, these are the disadvantages of the pipeline processing. What is the difference between Risk and Cis processors? Risk stands for Reduced Instruction Set Processor or Computer. So, it is a microprocessor architecture with simple collection and a highly customized set of instructions. But it is used to minimize the instruction execution time. So, here the RISC architecture majorly simplifies the hardware by using instruction set composed of few basic steps for loading, evaluating and storing the operations. And here this is the RISC architecture. Two caches are available here for the main memory. One is the instruction cache, second one is data cache. So that the instruction and data at a time can be available and executed of instruction can be carried out in a single cycle with the RISC architecture. So, the major feature of RISC are one cycle execution time and overlap execution can take place so that pipelining techniques can be used. A large number of registers can be available so that data and operands can be readily available for the execution of instruction. And it supports simple addressing mode and fixed length of instruction for executing the pipeline. It uses load and store instructions so that operand and instructions are readily available. Simple and limited instruction reduces the execution time of processor in a RISC. So, example of RISC architecture are ARM architecture, MIPS architecture, OpenRISC, Spark. What is CISC? CISC stands for Complex Instruction Set Computer. It is developed by Intel Corporation. It has large collection of complex instructions. So here single instruction will do all loading, storing operations, and the complex instruction set can have large number of instructions. So execution time can be more in the Cis. And here the Risk and Cis are aimed to increase the performance of the computer. And the Cis architecture is here only one cache. Both instructions and data frequently used can be cached here, and they can be readily available for memory and control unit for execution of instruction. The features of Cis are complex instruction and complex decoding process. Instructions are longer than one word size. Instructions may take more than a single clock cycle. And less number of general purpose registers can be available. Complex addressing modes are available, and but uses more data types. The example of Cis are 8086 and Z architecture instruction set and Intel 8080. And what is the difference between Risk and Cis? So whenever instruction types can be considered, Risk is simple, Cis is complex. When you consider number of instructions, it is reduced in the Risk generally few number of instructions. So 10 to 30 instructions. In Cis it can be 100 to 200 instructions are available. Duration of an instruction is only one cycle in the Risk. More than one cycle, generally 1 to 100 cycles for the Cis. Instruction format is fixed in the Risk and variable in the Cis. Instruction execution can be parallel, pipelined in the Risk, sequential in the Cis. And addressing modes are simple in the Risk. In the Cis, they are the complex one. Instruction accessing the memory can be load and store architecture, but it is all from the set. Register set is multiple in case of Risk, but unique in Cis. Complexity is in compiler in the Risk, in CPU in the Cis. So these are the differences between Risk and Cis. What is pipeline cycle time? The pipeline cycle time is calculated with the formula maximum delay due to any stage plus delay due to its registers. So the computational task can be divided into segments. What is the delay for each segment and what is the delay due to operand access in the register. The sum of these two can be considered as pipeline cycle time. What is arithmetic pipeline? Arithmetic pipelines are majorly used for high-speed computer. They are used to implement floating point operations, multiplication of fixed point numbers. Like these applications, the arithmetic pipeline can be used. The arithmetic pipeline divides the problem into sub-problems, and these can be carried out in a dedicated segments of the pipeline. Consider one example here, that is floating point adder pipeline. Two floating point numbers are considered. Capital A into 2 power A, Y is B into 2 power B, and the numbers that are considered for X and Y are these. The capital A, capital B are the mantissas, small a, small b are the exponents that are considered in the example. So the combined operation of floating point addition and subtraction is divided into 4 segments. This task is divided into 4 segments. What are those 4 segments? The first one is compare the exponents by subtraction. Second segment is align the multisource. Third one is add or subtract the multisource. Fourth one, normalize the result. So in segment 1, what are the sub operations? So the exponents are compared to determine by subtracting and to determine their difference. So in our example, the considered exponents 3 minus 2, that is 1. So this result is used to larger exponent is chosen as the exponent of the result. Second segment operations are the multisource associated with the small exponent is shifted according to the difference of exponent determined in the segment 1. So that here the exponent of y can be adjusted so that 0.0882 into 10 power 3. Thereby the aligning the multisource can be occurred. The third segment is the 2 multisources are added in segment 3. So the addition of multisource can be carried out. Normalize the result so that it can be the result, some value can be represented as 0.1324 into 10 power 4. So these are the 4 segment operations. And these segment operations can be illustrated with the flowchart. During segment 1, compare the exponent by subtraction. And the second segment is align the multisource. The third segment can add or subtract the multisource. Fourth one is normalize the result. So in this way, parallelly, the segment operations can be executed. So in this video, I have discussed the terms and definitions related to the module 5 multiprocessors, and the references that are used in this video are Computer System Architecture, a textbook of Maurice Mann, Computer Organization and Architecture textbook of William Stallings, and a web reference can be used. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.